Welcome. Thank you for joining us today for Quantifying Data Center Efficiency, a guide to achieving value in IT infrastructure management. My name is Raleigh Gould, and I will be moderator for today's event. Our featured speakers are Steve Brasen, Managing Research Director at Enterprise Management Associates, Sev Onyshkevych, Chief Marketing Officer at FieldView Solutions. Steve brings over 20 years of in-the-trenches enterprise experience in IT management, operational support, and engineering. At EMA, Steve's expertise is focused on systems management with a particular focus on endpoint management, configuration management, and green IT. In his role as CMO, Sev is responsible for strategy, branding, communications, business development, and international expansion at FieldView Solutions. Prior career experience includes serving as CEO at In Vino Veritas Consultants, global marketing at Raritan Computer, as well as president at Raritan Computer Japan. And I hand things over to today's featured speakers. I want today's audience to know that Steve will be concluding their presentations by answering your questions. Please do feel free to log them at any time throughout the course of the presentation by using the Q&A functionality located in the right-hand column of your screen. If you're in full slide view, simply look for the floating toolbar. You'll see a question mark icon. Click on that, and you can log your questions that way. Today's event is being recorded, and you'll be receiving a follow-up email from Enterprise Management Associates that will include the on-demand recording as well as a PDF of the speaker slides. I'd like to go ahead and turn things over to our first featured speaker, Steve Brasen. Steve?
Thank you much, Raleigh, and thank you all for joining us today as we reveal the true value that can be achieved with the introduction of IT infrastructure management processes and solutions. The focus of this presentation will be to identify opportunities for achieving greater efficiencies in IT infrastructures that will hopefully result in performance improvements and quantifiable cost reductions. To exemplify these process improvement opportunities, FieldView Solutions actually sponsored EMA to perform some primary research on organizations that have successfully adopted data center infrastructure management solutions and determine specific areas of value that can be achieved. Of our presentation today, we'll be revealing for the first time some of the research results from this evaluation as well. A quick look at our agenda. We'll start with an overview of data center infrastructure management. This will help to us define the scope of the management processes that are used to attain IT infrastructure efficiencies. Next, we'll briefly discuss the key areas where value can be attained from adopting infrastructure management best practices and introduce the evaluation processes we performed quantifying return on investment with these solutions. In specific, we'll talk about how to achieve improved energy efficiencies through a direct reduction in energy consumption, as well as through effective management of thermal conditions in the data center. Also look at the cost of ongoing operational expenses and how increased infrastructure visibility can reduce unnecessary expenses. And we'll consider how reducing IT support complexity will improve administrative staff efficiencies. And finally, we'll discuss some of the indirect value that can be achieved by ensuring IT infrastructure reliability. Data centers are extremely complex environments housing essential IT resources for achieving business requirements, of course. The combination of these two elements, complexity and enterprise dependency, increases the need for reliability and makes IT infrastructures very challenging to maintain. Changes to the environment are often introduced so rapidly and so frequently that it is just not possible to make strategic decisions about optimal configurations for hardware, cabling, network devices, and environmental control units on the fly. For example, think about the common use practice of installing a new server. Traditional data center management practices involve the very non-scientific method of walking through a facility looking for available rack space or co-locating a new server with IT equipment utilized by the same business department. Power cables are often just plugged into the nearest outlet, and at best, the devices are tracked in a simple document like an Excel spreadsheet. any ability to pre-plan the deployment, there's no telling what effect new devices will have on an environment. This is how organizations quickly lose control over their data centers and end up spending the bulk of their support resources on systemic problem firefighting. Unplanned infrastructure deployments result in excessive cost for operational resources like power and cooling, while dramatically reducing the reliability of production equipment. To be fair, IT managers and administrators should really not be fully blamed for dealing with disorganized data centers. They're typically just too busy managing day-to-day operations to effectively implement process improvements. Limited budgets, limited staff, and other limited management resources all contribute to an inability of IT support organizations to move beyond reactive problem resolution to proactively introducing environment efficiencies. And this is compounded by new levels of complexities that are being introduced and are necessary to support technologies such as virtualization deployments, cloud infrastructures, and consolidation initiatives, while meeting very stringent service level agreements and regulatory compliance commitments. Part of the problem in these out-of-control data centers is principally that they lack the visibility into the environment, or if they are collecting infrastructure details, the information is too complex for them to quickly and accurately analyze. A center is really an ecosystem of technology components. Every element interacts in a variety of ways with every other element. So when a change is introduced into the environment, it has an effect on every other infrastructure component. So for example, when a server is added to a rack, it draws more energy, and the power distribution node it increases ambient temperatures that directly affect the performance of every other server and IT component in the physical vicinity. These neighboring devices overheat or have inconsistent power, they could experience serious problems and flood the network with error messages or fail to provide services to other production systems. Complex chain reaction makes it difficult to identify the root cause of a problem. IT administrators are unaware of the detailed interactions of the data center elements. Data center infrastructure management encompasses all the monitoring and management processes necessary to enable a holistic view of the environment, dynamically recognizing the relationship of any single device to all the others. It is to recognize that this goes beyond just data collection. A DCIM solution must be able to rapidly analyze complex data center configurations and environment conditions to immediately indicate to administrators problems, potential problems, and opportunities for improvement. The goal of DCIM is to arm data center managers with the key information they need to make informed decisions about the planning, optimization, and ongoing maintenance of their IT infrastructures. Because DCIM is intended to provide an end-to-end solution for supporting the entire IT infrastructure, it encompasses a wide variety of management processes. I've listed here the essential monitoring, analyzing, and reporting capabilities that should be provided in any DCIM implementation. For asset and inventory management, the solution should collect attributes and status details for all physical devices in the data center and record that information in a centralized data repository. Collected asset data must be modeled to enable a holistic view of the complete physical, virtual, and environmental IT ecosystem. And models should ideally be graphically imaged to enable easy identification of physical asset locations, configurations, and status. The more detailed the data center imaging, the more rapidly administrators can absorb infrastructure conditions and make decisions on environmental optimization. On energy consumption and distribution of the entire powertrain should also be recorded. It includes data for individual devices, racks, PDUs, UPSs, circuits, on-site generators, and provider substation feeds. Energy consumption should be historically tracked, metered by use, and allowed to ensure power caps and other limitations are not exceeded. Management collects data on heat conditions across the infrastructure from live readings taken from sensors, chillers, and other temperature recording devices. Ideally, thermal data should be visually modeled and mapped so that administrators can rapidly identify hotspots and reduce costs related to cooling. Capabilities include the identification of available data center floor space and rack space, weight capacities, as well as power and networking availability. Is certainly essential to identifying the status of the environment, indicating areas for improvement and achieving proof of compliance. Reports should identify critical IT health conditions across the infrastructure. For example, power usage effectiveness ratings, or PUE, should be continuously calculated and reported to provide a key indicator of the level of computing energy efficiency in relation to total data center environmental costs. Alarms should also be provided to immediately alert administrators when conditions such as power, temperature, or performance spikes exceed established thresholds. Organizations that engage in environmental certificate trading or are subject to related regulatory compliance will also require periodic reporting of energy consumption and their associated carbon generation. Data infrastructure management has an effect on every aspect of data center cycle. It manifests value in a very broad range of business-focused improvements. Principally fall into two distinct categories, direct value and indirect value. Direct value is the one we most often talk about because it's quantifiable. It includes direct cost reductions that can be measured and tracked over time to provide visible ROI on data center improvements. Any costs associated with device power consumption and environmental cooling are certainly the most visible evidence of improvements. Some organizations need only look to their monthly electric bill to find proof of cost reduction. But it's usually a little bit more complicated than that since most data centers are in a constant state of change. So it's not apt to just compare bills month to month. Simply, though, the cost of hardware, maintenance, and administrative staff to keep the data center fully functional also requires a multifaceted view and what's happening in the data center to quantify accuracy. But it is possible to actually identify this and track operational costs. Much difficult to attribute to DCI processes are the indirect value areas. For instance, improved reliability. It's hard to quantify exactly how much money is saved in preventing data center failures, but I think we all understand the substantial consequences IT downtime causes to a business reputation, productivity, and profitability. IT managers, however, do often track IT availability as part of SLA requirements. So even if they can't attribute a specific dollar amount to reliability, they can often recognize improvements. Management processes can also improve administrative staff efficiency, but that's difficult to quantify because they use any saved time to address other business-related IT issues. A compliance achievement can actually fall into either category. Now, there is a direct value if the organization is involved in energy certificate trading or a power provider is offering energy reduction incentive programs. But there will also be indirect value if compliance goals were internally created to address social responsibilities, such as reducing carbon footprint and other environmental impacts. Organizations recognize all these areas of value, but ask question whether it's actually worth the effort to introduce a DCIM process. Now, to answer that question, FieldView Solutions sponsored EMA to perform research on organizations that have adopted its product set. By performing live interviews and submitting written surveys of existing few customers, we're getting a pretty clear picture of the key areas where value has been attained. FieldView sponsored this research. All the results were independently and objectively attained and analyzed by EMA. Now, to be clear, we've all heard and read about those uber-efficient data centers that were purpose-built from the ground up to run minimal energy and with maximum efficiency, with wind turbines in the backyard and 3 buckets of water for cooling and whatnot. Now, that's not what we reviewed. That'd be the point in that, really. These are typical data centers with all the day-to-day challenges and bizarre legacy histories you're probably experiencing in your own company. And this research is not over yet. We're still collecting data. But I think it's valuable for us to look at some of the case studies we're reviewing as examples of efficiency improvements from DCIM adoption. And at the risk of sounding like a Dragnet rerun. I should also note that we promised not to reveal the names of the IT managers we interviewed or directly identify their companies. A minute ago, the names have been changed to protect the innocent or something like that. We are talking about organizations that have adopted the FieldView platform. Introduction of the solution set is in order. FieldView Solutions data center and infrastructure monitoring software is designed to gather, store, and report on data center, device, and environment information to enable informed decision-making for optimal infrastructure planning. Trending is performed on collected data and displayed in a dashboard view, providing reporting at a glance on site efficiency, power consumption, PUE, space utilization, and other statistics. The releases of FieldView introduced heat mapping capabilities, which directly interpret data from environmental sensors to create a thermographic image of the data center. FieldView architecture includes multi-tenant features designed to address the needs of both enterprises and service providers that support SaaS and cloud infrastructures. And we released the EMA Radar Report on Data Center Infrastructure Management, which is our extremely detailed evaluation that compares premier solutions side by side. In the report, FieldView was recognized as a value leader for delivering broad functionality while maintaining cost effectiveness. Onto the actual processes for improving data center efficiency. Start with the methods for directly reducing device energy consumption. Servers are rarely utilized for their full capacity. By reallocating resources so that a smaller number of servers are being utilized at greater capacity, the unused systems can be retired along with their associated power consumption. Taking that concept a step further, a large number of systems can consolidate their processes onto especially large capacity servers, such as blade servers and mainframes, which are designed to draw proportionally less power and operate with greater efficiency. This process can also be employed when expanding data centers by adding new workloads to existing servers rather than adding new power-consuming devices. Hardware devices and components can also provide significant opportunities for reducing power consumption. Disks, chipsets, power supplies, and cooling systems are continually being redesigned to achieve greater standards in energy efficiency. Virtualization implementations also expands on the concept of server virtualization, server consolidation by allowing a single physical system to host multiple logical systems. Here, multiple servers can be consolidated onto a single or only a few large servers to take advantage of their improved power utilization features. Also, by sharing system resources and performing advanced memory management functions, virtualization solutions can significantly increase the overall computing efficiency of IT components. Management includes automated processes to shut down systems when they are not in use, and CPU throttling reduces energy consumption on devices during periods of low use. Now, this all sounds great in theory, right? But in reality, it's not always clear which data center devices would be candidates for improvements or reconfiguration. This can really only be performed by holistically monitoring the environment over time and pairing historical records of energy consumption against system use. The task is greatly simplified and made more reliable when alarms and triggers that indicate when devices have exceeded established thresholds have occurred, and they become candidates then for replacement or improvement. Here are the results of some surveys research we performed on IT managers of organizations that have actually introduced energy reduction initiatives. As you can see, server consolidation, hardware upgrades, and virtualization were all very popular methods employed for directly reducing data center energy consumption. And the same group of respondents exactly how much of a power cost savings was achieved since introducing the energy reduction processes. An overall average of 19% was reported. Now, they're a bit lower and a few were much higher, but if you consider the general expectation of reducing data center energy cost as a fifth of the total energy consumed by the data center, it clearly indicates time and effort well spent. In our recent case studies, a respondent noted that they were looking at consolidation as a way to reduce energy costs, and he gave some estimates on what he expected to achieve. A group of roughly 1,000 servers, the majority, maybe 80%, are only using 10 to 15% of their CPU capacity. Now, this is actually very typical. Additional server management practices require significant over-provisioning of devices to account for unexpected performance spikes and to ensure continual reliability of the platform. Monitoring and alarming of the devices, there's just no way to ensure that the server will not experience performance degradation. Through consolidation initiatives that enable load balancing and are monitored to ensure continual high performance, the 1,000 servers they indicated in the study expected could be reduced to about 600. Now, a little basic math on this, and assume the original 1,000 servers were drawing a typical average energy consumption of 0.5 kilowatts per hour, and the consolidated 600 servers are operating at a higher capacity, so drawing maybe 0.7 kilowatts per hour. And based on the total annual energy savings from the consolidation project would be 700 megawatts per hour, which would translate into reducing annual energy costs by about $84,000 and reducing carbon footprint by 150 tons of CO2. Just a measly 1,000 servers. Now apply this to an organization supporting tens of thousands of servers. We're talking about some serious cost savings. Servers aren't the only devices that draw energy in the data center, and just as notable are the environmental units necessary to cool the environment, generate heat, a lot of heat. And if they aren't kept cool, they could fail. Actually, they could fail spectacularly. I've certainly seen a number of this happen more than once. So keeping the environment cool is absolutely essential. And to prevent disasters from happening, data centers are often chilled to temperature well below necessary tolerances. This is due to a number of reasons. For example, if excessively heat-generating systems are clustered in a particular area, it can cause a hot spot. The temperatures would be reduced for the entire data center to ensure proper cooling of that one specific location. Airflow is another factor. Chilled air can pool up in one section of the data center if it does not have a clear path to circulate around the space. And cooling units themselves may not be placed in optimal conditions where they can do the most good. Data centers lack the visibility into their thermal conditions of their environments. They excessively lower ambient temperatures just to be on the safe side. Using DCIM visual modeling and thermographic imaging provides organizations with an easily digestible method for identifying hotspots and other thermal challenges and quickly fixing them. To be accurate, the temperature data should be directly collected from sensors and other live recording devices rather than just estimated. The visual representation also provides data center managers with the assurance that appropriate conditions are being maintained in the data center. We can't really address flow management without discussing at least a little bit power usage effectiveness, or PUE. This is probably the most commonly adopted metric for identifying data center efficiency. It's a very simple calculation. If you take the total data center facility consumption, including things, servers, chillers, lighting, alarms, sensors, security devices, everything, and divide that number by just the power consumed by IT equipment, so servers, storage units, network devices, and so forth. The result is the PUE ratio. Average data center PUE is about 2.5, meaning 1.5 times as much energy is consumed by the environmental units than by the IT equipment that's supporting them. And the bulk of that excess is for cooling. Now, it would certainly be ideal if you could get a PUE of 1, but a more realistic number is about 1.6. Some organizations target a little bit higher, some target a little bit lower, but that should give you an idea of what would be considered an acceptable number in most organizations. with PUE as an efficiency indicator, though. This is only really useful environments that are essentially static. If the data center is rapidly growing or consolidation initiatives are being performed, the P value may go up. Overall energy consumption costs go down in relation to the amount of computing activity being performed. Now, this is simply because high densities of equipment generate more heat and require more cooling. To accurately gauge improvements, you need to compare results from infrastructures that have not changed equipment densities, but that have made adjustments to environmental conditions. This is a consideration in one particular case study we looked at. The organization managed multiple customer tenants co-located in a single facility. The temperatures were initially kept excessively low to ensure customers that IT resources were reliably supported. After FieldView was adopted, however, they were able to slowly increase ambient temperatures by about 1 degree or so, roughly once a week. And they graphically showed their customers that there was no impact to the production environment. Settling on an ambient temperature of 55 degrees, the power consumption of the chillers actually dropped by 40%. While this was going on, the organization was in the process of a massive data center build-out, increasing floor size by 80% and load densities by 74%. Remember, increased load densities will result in higher PUEs. In this case, because they were able to increase ambient temperatures, the PUE actually decreased by 17%. Not been able to make this environmental improvement, overall energy consumption would have been 15% higher, resulting in an annual increase of 2.3 gigawatts of power, would have translated into a whopping $285,000 energy bill annually, and more than 2,700 tons of additional CO2. If I'm not mistaken, 2.3 gigawatts is actually twice as much power as Marty McFly needed to go back to the future. So just something to keep in mind if you happen to be time traveling. Another case that we looked at also involved an organization that was performing a major expansion project and specifically adopted FieldView to help optimize the implementation. In the process, by providing them with the intelligence necessary for deploying optimal configurations on both direct device energy consumption and thermal conditions, FieldView was directly responsible for enabling the organization to achieve a 15% reduction in overall power costs for a total savings of $600,000 per year in related energy consumption. All cost reductions are undoubtedly the most visible achieved from DCIM adoption. They are by no means the only efficiency improvement. Operational costs are also affected in poorly managed environments that lack infrastructure visibility. For example, power spikes and hotspots damage or impact the performance of critical data center devices. Continue monitoring the environment and alarming on potential problems can identify issues before they become impactful to the environment. Further, it can actually extend the life of hardware components by providing the assurance that they are functioning properly. And of course, with automatic reporting of hardware reliability, administrative staff are not burdened with the need to perform time-consuming audits. I saw a great example of this in one case study where a company had concerns about the reliability of the branch circuits supporting their IT infrastructure. Although they periodically performed manual probes of the branch circuits, and it was a very time-consuming process, and only provided a snapshot of the status of the environment that would quickly become outdated because things change so rapidly. To avoid risk, they regularly replaced branch circuits to ensure reliability. They didn't think the circuits were good or bad. They just blindly replaced them just to be on the safe side. The organization adopted FieldView specifically for branch circuit monitoring capabilities and saw immediate returns. They estimate roughly $90,000 is now saved annually in manual labor alone. Add to that the $20,000 in new circuits that they were unnecessarily replacing each year, and you get a total annual operation cost reduction of $110,000. A note of reducing administrative support efforts. Consolidating infrastructure monitoring provides many opportunities to simplify IT operations. According to our research, an average data center incident takes roughly 4 hours to resolve, with half of that time taken to identify that the problem actually occurred. Graphical dashboards provide administrators with an immediate identification of issues and gives them direction on the root cause of the problem, reducing both mean time to detection and mean time to resolution, as well as preventing systemic infrastructure problems that cause IT operations to get stuck in the fixed cycle of consistent reactive firefighting. The less time support staff spend chasing down environmental failures, the more time they have available to further improve the infrastructure, address more business-focused IT projects. The company reviewed was very clear about the reductions in administrative effort they experienced. With limited support personnel, the organization was frustrated with the time-consuming processes they performed for capacity management. Every time a new project was introduced, a manual audit of all racks needed to be performed to identify an individual location and optimal configurations. A week's worth of work for an administrator, which they were able to reduce to only about 20 or 30 minutes with the use of FieldView's built-in reports. So we're doing these audits at an average of maybe once per month. That's the equivalent of more than $35,000 to cover the administrator's salary and other compensation. Or putting another way, that's $35,000 worth of effort that was redirected into more productivity supporting the business. Reliability of the infrastructure certainly falls into the category of being one of those indirect value returns we discussed earlier. If IT performance degrades or failures occur, it could have a direct impact on the business with real financial impacts. Project failures, missed deadlines, and angry customers could all lead to direct revenue losses. Also, fines may be levied if the organization fails to meet compliance or SLA objectives. Reliability and business continuity are both issues of primary importance to data center management. Maintaining them requires visibility not only into the current data center state, but also into the power conditioning and failover chain to ensure that they are fully functional and available if needed. That was a primary concern to one organization we spoke with that brought FieldView specifically to ensure better reliability and stability of their IT infrastructure. Examples of this included the ability to easily and continuously monitor circuits and power loads to ensure they were operating efficiently. They also noted the ability to look at power distribution records historically as something that was essential to them to identifying trends and making critical adjustments. And able to be strategic in the deployment of new equipment thanks to the detailed capacity information the solution provides. But at the core, this is what DCIM is really all about. It's about arming data center managers and the critical infrastructure intelligence they need to make informed decisions about optimal configurations. The value that can be achieved from a solution such as FieldView is quite extensive, both in terms of direct cost reductions and indirect environmental effectiveness. And one note that I'd like to make, as viewing the various customer cases, it became blatantly clear that although they all found the value from the solution in different ways, they were all extremely happy with the platform and with the support they've received from FieldView. On this page, just a few of the testimonials that I squeezed into one page, but there were a lot others. And on that note, I'd like to turn the presentation over to Sev to provide us with some additional information on FieldView. Sev?
Also, thank you everybody online. Just a few brief words of introduction about FieldView, and then we can move on to the Q&A. So FieldView, being a data center infrastructure management vendor, we're an independent. We're one of the few major independents in the space. Many players that are in the DCIM space are in the space to sell hardware, to sell temperature sensors, to sell power strips, and to support their heating and cooling and environmental equipment. We focus exclusively on software. We're in the USA, but we have a global footprint. We have data centers using FieldView software on 6 continents around the world. We're a mature product that's coming up on our 16th release soon. We have domain experience on both the facilities and the IT side. We've been used in over 1.5 gigawatts of power across more than 200 locations around the world. We're on the high end of the market, ranging from 1 megawatt to well over 100 megawatts of power at one location. Well, fundamentally, is we read data directly from a variety of equipment. This ranges from the utility feed outside to the motherboard inside the computers and everything in between. That's your UPSs, your PDUs, your generators, your CRECs, your chillers, your power strips, your temperature sensors, and any other piece of equipment you have. So consolidate information that you may have in BMSs, EPMSs, CMDBs, IT systems management, and various other tools. All that allows us to monitor and alert on both power and environmentals. Data is used to identify and make improvements on both the facility side, that is your cooling and your power, as well as on the IT side. The mind is that you cannot improve what you cannot measure. Customers improve their uptime. We help them save energy on both the power and the cooling. In economy, one of the big deals is deferring capital expenditures. If I can defer a $400 million data center build out, that's a very quick payback on investment. Involved in 6 of the top 10 banks in the world, 2 of the top 5 IT vendors, 12 major colo providers, and government agencies, and other large and very large data centers. We also have special features that are geared to empower both the owners as well as the tenants of the facilities in a very secure and reliable fashion. We have multiple views, both for the facilities and for the IT people, as well as the IT operations and senior management. Aggregate and integrate disparate islands of monitoring on both the facilities and the IT side. We have 6 predefined reports, as well as a built-in business intelligence module. We export and link to business intelligence tools of your choice. We help find unused capacity in both space, in both power and on cooling. We're the largest independents in this space. We work with every vendor on the IT side. We work with every vendor on the facility side. We help you minimize the risk. We're very easy to install. We've had installations with 15,000 data points monitored that are live in virtually one day. I'd like it over to you, Raleigh.
Great, thank you, Sev. We're going to go ahead and jump right into the Q&A session of today's event. Before we do that, however, I did want to point out some additional resources from FieldView. These will be part of the follow-up email that you will receive from Enterprise Management Associates tomorrow, so look out for that email. Let's go ahead and jump into questions. Again, you can log them using the Q&A functionality. You should see that in the right-hand column of your screen, or if you're in full slide view, look for the floating toolbar. You'll see a question mark icon, and click on that, and you can log your questions there. So with you, Sev, this audience member wants to know, what does need to look for in a DCIM solution?
I think there are a couple aspects. One is you're looking for a DCIM solution that will span both all the equipment that you have on the facility side and the IT side today in terms of the vendors, as well as have the flexibility for expanding that in the future as you change vendors, as you consolidate facilities. Security is fundamentally important. A number of DCIM solutions allow you to control both the cooling or the power chain and or the IT chain. The design and the architecture of the system needs to be able to separate those functions. We do that by integrating with different solutions for control, but our solution itself, in order to reside on the corporate network, explicitly excludes that control element. Multi-platform in terms of the clients. Don't look for a solution that requires installation of client software of, say, a Windows application. Look for a browser-based solution. Steve, you have anything to add?
Yeah, sure. And that's actually a great question. It certainly offers there's a lot of confusion and misinformation out there about DCIM in general, and there's a lot of products that are claiming to be DCIM solutions that are not. They're point products. They all do is monitor energy consumption, or all they do is track devices in the data center. That's not data center infrastructure management. Data center infrastructure management requires at least three components. The first would be the ability to track and record information across both all the devices in the data center as well as the environmental conditions. It also has to have a method for modeling that information and hopefully visually modeling that information. And third, it has to have the ability to perform analytics on the data and reporting so that the information on the conditions of the environment and improvements are easily digestible by the users.
Great, both very good information to have. Jumping back over to you, Sev, this audience member wants to know how small of an environment would use this?
We have locations that are as small as 1,000 square feet and range up into the several 100,000 square feet, and even multiple locations in one campus going over 1 million square feet. But 1,000 square feet would be generally the minimal size. The more locations, the more space you have, the more value we can provide. But we find that there's an ROI and a payback for locations even as small as 1,000.
Great, good to know. Here's an interesting question that I'll throw out to both of you. What will DCIM look like in 10 years, in both of your opinions?
I'll go first on that one. And obviously, 10 years is a long time. It's easier for me to predict 2 or 3 years, but 10 years, things will change substantially in the data center. And certainly the direction everything is going, we're looking at with adoption of cloud and virtualization and so forth, looking at a increased consolidation of data center resources. So on the one hand, we're looking at greater consolidation, but on the other hand, greater increased need for reliability in the data center. High availability is absolutely critical. So the responsibility for data center infrastructure management actually increases. Where this is all going is providing this holistic view of DCIM that crosses both siloed management organizations that we often see in large enterprises. One would be IT operations, that are responsible for managing the actual devices. And the other is facilities management, which manages the data center itself and the environment. So going forward, what we would expect to see are DCIM solutions that don't just look at environment, although that's important, but also look at servers and server consumption and creates a holistic view across both environments, so a single console, a single pane of glass can be used by administrators to identify problems and potential problems anywhere in the infrastructure.
From perspective, I think there will be a few trends. We see some demands for open standards for interconnecting DCIM tools, as well as a number of the application layers that work on top of the DCIM tools, as well as many of the data collection elements that plug into them. We also think that the philosophy will change, and ultimately what people will want to measure is the power consumption per useful unit of work. Today, PUE is a step toward in that direction, but ultimately you want to actually look at what's happening on the server, how useful that is, and how much that's costing. you all want to move the point of thermal control from the outside to the side of the server, because after all, the only part that you really need to cool are the chips. And as you move that thermal point and you change the philosophy of the control point to go from cooling the air outside, the actual temperature doesn't matter. What matters is the temperature in the chips themselves. And I think that will be the ultimate data point that drives the entire thermal chain.
That's a great insight, Sev. I just wanted to chime in on that. About the PUE, I really wholeheartely agree with that concept. The challenge with PUE today is, of course, it only determines IT, the use of IT by the amount of power being consumed by the IT devices. But what you really want to look at is the amount of processing being performed by the devices, its usefulness to the business. And, of course, that requires a much broader level of data recording in order to come up with an accurate number on that, and then compare that against actual costs of managing the entire data center.
Great, thank you both. Speaking of trends, this audience member wants to know, with the trend to raise temperature in data centers and reduce or eliminate cooling equipment, does that eliminate the need for DCIM? Thoughts on that, Sev and Steve?
I think it's actually quite the opposite. As you reduce safety margin by raising the overall temperatures in the data center, monitoring becomes more important to ensure that whatever it is you're doing doesn't get closer and closer to the limits of tolerance. So we welcome that trend. We think it's a wonderful opportunity to squeeze a very substantial chunk of the power bill out of a data center. But in order to operate that effectively, you really need a monitoring solution that helps you make that, turn that into practice in a very safe and reliable way.
Yeah, absolutely agree with that. We had feedback from several of the case studies on exactly that point. It wasn't a matter of, it was less of a matter of them of wanting to find a way to reduce energy costs as it was to reduce energy costs and then confirm that did not impact the production environment. And what we found is in quite a few cases, they were wastefully had lower energy costs and were doing other kinds of, wastefully had lower temperatures and were doing practices that were totally inefficient just because they were afraid that there might be some impact to the environment. They just didn't know, they didn't have the confirmation. So monitoring the infrastructure is also key. There's also a point to be made here about the transition into this. I mean, you want to introduce new hardware devices, but unless you're building a data center from the ground up, you really need to make strategic processes for upgrading the environment in ways that will not be impactful to production. You certainly need some sort of a monitoring solution like FieldView supplies to do that accurately.
Great. Steve, there are a couple of questions regarding the case studies you mentioned in your portion of the presentation. The first one is, what is the primary reason organizations adopted FieldView? Was it to reduce energy consumption?
Yeah, actually a few did, but I have to say in general the solution was brought in to improve infrastructure reliability or to assist with a specific project like a data center build-out or migration project. Now, that's not to say they didn't achieve improvements in energy consumption, but the reason that that they claimed that they adopted the platform is usually for a larger project. This is actually pretty consistent with DIM adoption in general. Despite the fact that there is a real substantial quantifiable cost savings associated with reducing energy consumption, organizations often introduce power consumption improvements as part of a larger project rather than as a primary goal. Research actually indicates that energy reduction initiatives generally have to be driven at the executive level. There has to be executive buy-in to actually reduce costs associated with energy consumption, rather than at the IT manager level, where they're focused more on day-to-day activities and are focused on reliability of the environment and achieving specific project goals. So hopefully we're bringing some more awareness to the huge financial value of achieving energy efficiency, and we'll see more executive buy-in to drive initiatives in this direction, and hopefully things will change.
And Steve, according to what you discovered from your research, did respondents indicate if FieldView was easy to deploy?
Yes, actually, indeed. Respondents talked quite a bit about being up and running in just a few days, and we heard nothing but praise for the support FieldView provided during the rollout. Several customers also mentioned that they use FieldView in conjunction with other management platforms and found it very easy to integrate the solutions. Also, training staff was also noted as being very fast and easy because of the intuitive nature of the graphical interface. Now, Sev, I know that as we were talking to them, we heard that during the deployment process, I know you guys put a good deal of effort into making sure that it's customized to meet whatever specific needs they have. Maybe you can elaborate on the deployment process a little bit.
There's a substantial amount of customization ability built into the tool set that our staff and or our customers can configure themselves. That includes the graphics, that includes the reports, that includes many of the formulas, that includes the dashboards that can be defined in many different ways. So there's a lot of flexibility built into the tool itself. We also will develop custom reports for them. We have only one code base. We don't make versions that are different for every single customer. So any improvements that are made into our solution be available to all our other customers. That's how we can offer more than 50 different predefined canned integrations to various calls, various pieces of equipment. That we have a wealth of built-in reports and dashboards. So it's been designed from ground up to offer that kind of flexibility. We also offer professional services for those cases where whatever we offer is not satisfying our clients.
Thank you. Here's an interesting question I'll throw out to both of you. This audience member would like to know, what is the best DCIM practice to focus on in order to reduce data center costs with minimal effort?
I'll tackle that one. You're talking about just data center costs, and we're not talking about increasing reliability. We're just talking about cost reductions. In my opinion, hands down, it's thermal management in most cases. Cooling is typically responsible, as we mentioned, for about half of the cost of a data center energy consumption, your average data center. And it's actually one of the easiest to fix if you have the visibility into temperature conditions. You move some devices around to distribute the heat better and raise your ambient temperature. Now, compare this to, say, a consolidation project requires the purchase and installation of new equipment, as well as the migration of workloads. That can be very time-consuming and costly if you're just doing it for reducing energy consumption. There might be other compelling reasons to doing a consolidation project. Another example would be virtualization, which has all of the challenges of consolidation plus a complex environment to orchestrate and manage. So my answer to that would be if you're just looking at immediate, as quick as possible, with minimal effort, reductions in data center costs, focus on thermal management.
I would agree with you, Steve. I think in general, the quickest bang for the buck is in the thermal side. However, there are some situations where they're contemplating a new data center build-out, and if you can do that build-out by essentially making more effective use of what you have already in terms of the space, in terms of power capacity, in terms of the clean capacity, and if you can cancel those projects, the ROI on those situations, if you happen to be in that situation, can be a matter of days.
Mm-hmm.
Thank you. Speaking of time, Sev, an audience member would like to know what type of time frame can they expect with this process?
The biggest tendency is in terms of the size. We've had installations that were up and running in a matter of days, less than a week. Typically, our customers have multiple locations. They'll have dozens of different islands of monitoring, existing monitoring, retrofitting, setting up the temperature sensors, and configuring and loading data. So that high end, from the kickoff meeting to turning over the key and training, would typically run 60 to 90 days.
What type of customization is involved?
I think, as we mentioned before, we customize the graphics to the particular configuration of the data center. We select the reports. We customize the formulas on the reports on the dashboards. We construct the reporting tools and the dashboards to the customer specifications. We adapt it to the customer's existing tools, whether we're integrating directly to the end equipment or we're integrating to, say, a branch, a building management system or a EMS. We'll consider both sets of data. So we customize at all those layers.
Okay, and what about other product-specific questions to replace an organization's BMS?
In situations, yes. In the vast majority of cases, we keep the BMS. The BMS will be used for control and used for monitoring. We'll either monitor directly and feed the control systems, or we'll pass through the data from the BMS. We also, of course, our span of control and monitoring goes way outside what a BMS does, as we go all the way to the servers, to the motherboards, various bits of equipment that are not connected, the thermal as well as the power chain. So all of that gets consolidated, and we would keep the legacy BMS focused on controlling that environment.
Great, thank you for that clarification. We're just at about the top of the hour, so I'm going to conclude the Q&A session. I wanted to thank all of you for joining us today and for your questions. As I mentioned previously, you will be receiving an email from Enterprise Management Associates tomorrow, and it will include the playback and all the URLs listed on your screen. Thank you for joining us, and enjoy the rest of your day.